these bottles or these products? No. Okay. These PLCs are connected to motors. Yeah, hardware machines. Exactly. Okay. These hardware machines can be motors, actuators. This can be pneumatic, electronic, okay, or hydraulic. These actuators are controlled by your PLCs. And why do we need PLCs? Because it's hard to manually control these machines. We cannot manually control belts every time we are manufacturing uh, uh, each stage. Let's say there is a stage where the bottles are labeled with the brand labels. So there is a machine that uh, enables a track belt to take bottles in front of each labeling machine, and it labels and puts it and delivers it to the another machine. Okay, so all these machines are working together, and uh, if we use a human interaction in between, so there is no use of using machines, because in the end a human is controlling it from the control center. So there is no use of using a CNC machine, which is why these machines are pre-programmed, and it has a source where it can take the raw material, it can process, it can apply labels, barcodes on the bottles, and then it will transfer it to another machine that will fill in uh, RO water, and then there is a machine that seals the bottle, and then it is passed on to another machine. That machine is responsible for collecting a batch of 24 bottles and putting it in a carton, and then it is sealed and stored to the storage room. Okay, are we clear? So now let's understand how is this programmed. Okay, so all these machines are connected to a bunch of PLCs, programmable logic controllers here. Okay, and Siemens S7-1200 PLC is one of the most widely used PLCs in the market, and these PLCs can take up to four analog inputs and give up to four analog outputs for the starters. And these analog inputs can be pulse width modulations. Okay, this can take pulses from the sensors. Let's say how do we detect a bottle that is on the turbine? So let's assume that there is an ultrasonic sensor, or there is a IR sensor that detects bottle, and it says, hey, there's a bottle on the turbine. This means that this needs to be filled. And then there is a machine that or there's a pipe that is pushed inside the bottle, and it's filled with exact 1 liter of water. So how does the machine give exactly 1 liter of water there? Because it is programmed that way. So Siemens have their own proprietary softwares to program these PLCs. And any idea how these PLCs are programmed? Anyone? Consider PLC as your microcontroller. Okay. Are you guys familiar with microcontrollers? If not, please let me know so that I can explain you. Yeah, okay. So, uh, yeah, okay. Thank you. So, as we all know that these microcontrollers are, okay. So, Rajesh, microcontroller is a integrated circuit, let's assume, and this microcontroller, okay, so for those who don't know what a microcontroller is, let's start with the microcontroller first. Okay, so that you can understand the PLC from the basics. Have you guys seen this board anywhere in your career? Yes. Yeah, so yeah, this is what we call as a microcontroller. For IoT project, exactly. So this is not only used for IoT based projects, it is also used for many embedded projects and projects where you need to run, yeah, exactly. So project where you used to where you need to run motors, actuators, or take sensor inputs and then process them in order to give outputs. Okay, so let's understand this microcontroller first because this is very similar to how a PLC works. Okay, so it has Atmega 328P. Atmega 328P is this IC here. Okay, can you see my cursor? This is Atmega 328P. Okay, and do you know how we can program these microcontrollers? Which language is basically used to program Atmega 328P microcontroller or Arduino Uno? C++, yeah. C and C++, both, yeah. Embedded C or C++ can be used to program. And this Arduino Uno is very uh, widely used hardware in IoT projects as well and many electronics and communication projects. But ever wondered how this C and C++ code is dumped inside your Atmega 328P? Like what happens when you write a code in a code editor and how you upload that code to your Arduino Uno? Because this is where your code is interacting with two different hardwares. You've written code in your computer and now it has to be executed in your MCU microcontroller. So how is your computer saying that, hey, these are a set of instructions that you are supposed to use and this is how you are supposed to function once you are powered on after the code is being uploaded? Instructions set by microcontroller loaded to register execute. Okay. So yeah, so these instructions are given to microcontroller and these instructions are iterated again and again. Okay. So for example, we can go to Tinkercad, okay, to make you understand this more easily. Okay. I think since most of you are familiar with Arduino, they might as well be familiar with breadboards, resistors, and multimeters, right? Yeah. Yeah, and if anyone is having a doubt in between, please feel free to ask or feel free to let me know if you're not understanding a few concepts here because uh, I'm starting from the very basic of PLCs because it's very important to understand, and this is one of the main reasons why OT attacks are successful because uh, let's assume that we have a 3D printing machine in MNIT, and there are a few faculties assigned to, use these 3D printing machines. Students come to these faculties and they say, hey, sir, this is my file and I want this to be 3D printed. And you guys are taught uh, uh, you guys are trained how to use these 3D printers and how to, print 3D files using these printers. And you don't know how to debug for issues there, errors there. Okay, so this is what happens. Let's assume there is a power plant. Let's assume NTPC for example. Uh, I think most of you know what NTPC is. It's a coal power generating plant situated in Mathura and like in the middle of Mathura and Agra, and it is responsible. It is the one of the major responsible for Taj Mahal's marble cancer. Am I right? So this let's assume NTPC for example, and NTPC generates power from coal. Okay, so they have set up a OT environment already to generate power from coal. There are turbines. There are water like there are water source which is evaporated, and the vapors are given to turbines, and turbines generate electricity, and these electricities are then distributed to power grids. So these power coal power generating plants or any other OT industry which has these PLCs and OT network setup, they don't alter or change the setup, or they don't upgrade the security instances, because they think that as long as this thing is working, it is okay. And when it stops working, we'll call up a team of mechanics or security engineers so that they can fix it. But as long as it's working, let's not touch it, because we don't know what all are the core components and what is happening in the base level. So which is why people are afraid to touch the PLCs or to alter with the firmwares. So now like basic understanding of these PLCs and how these codes are executed in these PLCs are very important. Okay, so let's take an Arduino Uno for example. This is our microcontroller. This is breadboard, and I have connected an LED to pin number 13. Okay, and there is a multimeter here. Okay, so let's check the code for first. Okay, so this is a C++ code, and I think if you see the code, it's self-explanatory what is happening here. We have declared a pin. As I told, we are using pin number 13. So we have declared pin mode 13 as output. So we are telling the microcontroller, hey, pin number 13 is your output pin, and we are going to use pin number 13 to give out output signals. Okay. And then there is a loop function. So loop is, is a function where you write the actual code, and this code is iterated again and again until the microcontroller is powered on or until you use a break statement. Okay, are we clear? Are we clear till here? Yes. Okay, so what have we written in our loop? We have written digital write pin number 13 high. So when the loop starts, we are telling the microcontroller to turn on the pin number 13, and high here means giving out positive 5 volts in this pin, and we are going to wait for 1 second after this, and then we'll give it a low signal. That means it will turn off. So this is a basic blink code. Okay, and when I start the simulation, this is what happens. Okay, the LED is blinking for 1 second and shutting down for 1 second. Okay, and you can see the voltage from the output pin. It is going up till 4.85 volts. And so whenever we are giving something, some analog output or some digital outputs are basically either high or low, and analog outputs are basically pulses with modulations. So with the help of analog outputs, we can regulate from voltage 0 to 4.85, let's assume. Okay, we can control the speed of the, like we can control the brightness of the LED, we can control speed of the motor. So in order to use these devices, peripherals, uh, we can use our Arduino code, like we can code the Arduino, and we can control uh, these actuators, and we can take analog inputs from the sensors as well. Okay, so now let's understand how this code is being dumped inside the microcontroller. Okay, this IC here is our Atmega 328P, and this code is being written in Arduino IDE. IDE is Arduino's integrated development environment, where you write this code, and it has a set of boards. I think I have Arduino IDE as well. So this is a software that is used to write down code, and I think most of you are aware. But still, for those who don't know what Arduino is and have never uploaded a code inside Arduino, so this is the software that is used. Okay, so this is our Arduino IDE. Here you're supposed to write your code, and from the left toolbar you can download boards, and in the tools you can select which board you want to upload the code to. Okay, there are multiple microcontrollers, and in order to understand which microcontroller you are using, you need to specify the board layout to your integrated development environment so that it can map pins for sensor input and actuator outputs. Okay, so similarly, this Arduino software is used to program code inside your Arduino microcontroller, and there are Simon's proprietary softwares that are used to dump configuration files inside your PLCs. Okay, so now we have written this code inside a microcontroller, and this code, once we approve the code, okay, so this is a code for max 30105 pulse rate sensor, and this is written for a not MCU board. Okay, so when I verify the code, this code is compiled and it is checked for the errors. Okay, so see, once the code is compiled, it is stored inside a hexadecimal file. Okay, it's a binary file because your microcontroller in the core understands binary file. It does not understand what a C code is or what a C++ code is. So it is converted into zeros and ones. Okay, and after the compilation is completed, we'll get a hexadecimal file location. Okay, and that file is uh, given to your Atmega 328P with use of this IC here. Okay, it is called CP2102. Okay, it's a USB to USART converter. This IC. Okay, this IC is called CP2102. Okay, it's a USB to USART converter, and with the help of your TX and RX pins, we basically send these zeros and ones inside your microcontroller. Okay, and once these set of instructions are given inside your microcontroller can iterate that code in loop. And this is the main difference between a microcontroller and microprocessor here. Okay, microcontroller can run one code into multiple iterations. So we can give a set of instructions to this microcontroller, and this will repeat that in iterations. Let's say this is a microcontroller that is programmed to make tea. So we have given a set of instructions. Okay, you have to boil water first, and then you'll have to add tea leaves. And then if you want, you can add other spices and then water. And once the tea is boiled, you'll have to boil it for some time, and then once it's boiled you have to strain it. So once this is given, these instructions are given, this will iterate those instructions in loop. Okay, and whereas in a microprocessor, these am I audible now? Please let me know if there is a
Yes,
break.
sir, you're audible.
Yeah, okay. So yeah, so microcontrollers are designed to run a single code file, and microprocessors can run thousands of codes in a iteration. They can run uh, operating systems. They can run embedded Linux inside, but microcontrollers are designed to iterate specific instructions. Okay, so with this told, can you guys differentiate where microcontrollers are used in your day-to-day lives and where microprocessors can be used? Anyone? Just give me two examples where we can use a microcontroller and two examples where we use microprocessors in our day-to-day life. Washing machine, okay, in customer electronic. Okay, so yeah, so in washing machines, we use microcontrollers there. Yeah, washing machine for microcontrollers. Yeah, okay. ACs also use microcontrollers. Ovens as well, they use microcontrollers. So these all are the appliances there which are pre-programmed. Yeah. So these are the appliances that are pre-programmed. Let's say there's a washing machine. So washing machine follows a set of instructions, and these instructions are, rinsing it with water. We'll have to bike, AC, all automatic machines. Exactly. So all these machines are given a set of instructions. Because once you wash your clothes in your washing machine, once you select a mode, let's say there's a mode called rapid 30 which washes your clothes in 30 minutes. So there are a set of instructions given. First 5 minutes you're going to add water, and then you're going to rotate the disk for next 15 minutes, and after that you're going to strain the water, and once the water is strained you're going to beep this alarm so that user knows that your clothes have been washed. So all these machines use microcontrollers. And what about microprocessors? Any uses of microprocessors in your day-to-day lives? PC, yeah, your computer. Your computer is a very good example of microprocessors, and your phones also have microprocessors. So now that we know, yeah, exactly. Now that we know the difference between a microcontroller and microprocessor, can you differentiate which, like, what is used here in your PLC? Is it a micro? Okay. So Mukul says we use microcontroller in the PLCs. Yeah, microcontrollers. So PLCs are designed to have a microcontroller unit, and this microcontroller unit can take sensor inputs and give outputs to your motors or actuators, which are whatever are connected. Okay. So now as per our scope, let's see how we can use these microcontrollers, and how can we control machines. Okay, let's say I have a motor. Uh, let's say I have a pump that takes water and it fills my tank, and I have a PLC attached there in my tank. It has a water level sensor which gives me live preview of how much water is filled inside the tank, and once the tank is filled it will turn off the motor. Okay, this is our scenario. Okay, for this scenario, how are we going to connect our PLC to the motor? Can we directly control our motor with the PLC? Can we? So I'll go to market, I'll buy a Siemens S7 1200, and I will connect my motor directly to my Siemens S7 1200, and I will connect my sensor to my PLC again, and I have programmed logic in ladder so that once the tank is filled and sensor gives out analog data, the pump stops, and once the water goes below a threshold limit, it will start filling. So will my approach work here? Is it capable of running my pump? Because we basically use three-phase motors. Can I run my water pump with a PLC? Come on, guys, give me a guess. No idea. Okay. So let's assume, yes, with the driver. Okay, Rajesh has written, yes, we can run it with the driver. Yeah, and Why do we use drivers here? Okay, let's understand what is happening here. Okay, so we have a PLC. Okay, and our PLC requires, this is our PLC, and our PLC requires 24 volts input, and this 24 volts input is again converted into multiple voltages. Okay, to power on multiple segments in your PLC. There is a microcontroller unit, there is a analog processing unit, there is a digital output processing unit. Okay, so all these units are powered from those 24 volts. So we have voltage converters as well. So most of the MCUs, they work on 3.3 or 5 volts. So these 24 volts is stepped down to 5 volts and given to your microcontroller, and we can and given to your output processing units and input processing units as well. But these 24 volts DC is not capable to control your motor, because your motor is running on 240 volts AC. So what we use here is called a motor driver. Okay. And in industry, we have many motor drivers. uh, if we are controlling DC motors, we have drivers like L293D or L298. So all these motor drivers are used to control DC motors, and there are motor drivers to control AC motors as well. So these drivers are connected to your PLCs. Okay, or let's say you have connected a relay to your PLC. Anyone is aware of what is a relay module? It's a switch, yes. So relay is a switch, you can say. Okay. So for our use case, let's say this is my PLC1. Okay. This PLC1 is connected to sensor. Okay. This sensor is collecting data from my tank. It's taking the water level data and it is giving it to the SCADA system, HMI. Okay. And this SCADA system will see how much water is filled, and it will represent a water tank in our human to machine interface, and it shows how what is the percentage of tank that is filled. Okay, this PLC is used here to take sensor input and give it to your SCADA. Okay, and it uses a protocol called Modbus when it is connected to Ethernet. Okay, Modbus is a TCP protocol, and it is used to send data inside your network. Okay, and this gives data to your PLC2, that is your actuator. Okay, so let's keep PLC1 and PLC2 in play here. Let's forget about PLC3 for some time, because our use case can be satisfied with a single PLC as well. But for your understanding, we're using two PLCs here. This PLC is further connected to a switch. Okay, and once you turn on that switch, it will turn on your pump, and your water will be transferred from your ground to your overhead tank. Okay, so this PLC will turn on relay or a triac. Relay turns on, relay connects your motor to power supply using a mechanical uh, switch. It has a mechanical switch inside, and it uses electromagnetic current to combine those two terminals. Whereas in triac, we electronically convert this. Triac is more like your transistor. It electronically connects those switches, and tracks are more reliable when compared to relays, because internally in a relay there are two terminals that are being attached, and triac is electronically connecting those wires. So you can use triac or relay. So most of the PLCs here use relays nowadays. So yeah, we use relay. This powers on a relay and that connects the motor, and then motor is turned on. So your PLC is not directly controlling your motor. We can use some sort of motor driver, or we can use some sort of relay to control these motors. And this sensor will give data through Modbus to your SCADA, and then SCADA will send data to your PLC saying that, hey, this is the water level of tank, and in order to maintain 80% of water, you need to fill the tank. And once the tank is filled, you can stop. Okay, so here what we do is we uh, set a threshold limit of maximum water percentage and minimum water percentage so that the limits are maintained here. Okay. Are we clear with this part? Any doubts still here? Yeah. So you guys might be no. Okay. Yeah. So I assume there are no doubts. Yeah. So yeah. So you filling out a water tank with PLCs and ICS is a very uh, easy example, but in a core use case, imagine this tank filled with liquid nitrogen. Okay, there is a company that is fabricating semiconductors. Uh, like I have worked with the company. It's which fabricates silicons and integrated circuits. So for that, it stores gallium arsenide to make semiconductors. And for those gallium arsenides to stored, there are multiple liquid nitrogen cylinders. And in order to maintain these levels, we use programmable logic controllers, because you cannot manually use someone, use an employee to go on site and turn on the turbine, turn on the input and output valves to maintain the level inside your tank, because this is very dangerous. And which is why, in order to you know s- make sure there is very less human involvement here, we implement industrial control systems here. Okay, so I think with this example, we are clear with how PLCs are connected. And in this scenario, in this connection anatomy, if you have any doubt, you can ask me right now before we proceed with more. Okay, so this is our Siemens S7 PLC. Okay, and this is our SCADA interface. This is how we can discover multiple PLC devices in a network, and there is no limit. We can have n number of PLCs as long as we are segregating these PLCs into groups. And if they are not being segregated, then it's a problem for you to understand which PLCs are giving you data and which PLCs are responsible for controlling motors, actuators. So they create a schematic diagram for all these PLCs for each and every plant, and interconnect these plants to show anatomy of a manufacturing plant or a power grid. Okay, so there are a few core components of PLCs that I have already explained. So it is CPU, MCU that I told you, or AISC. These are basically ARM-based microcontrollers. So now that we were seeing at Mega 3 to 8P here, this is for our projects and home use, and we can make few IoT projects. But for industrial purposes, we use ARM-based microcontrollers or industrial grade microcontrollers like STM32F103 RT6. That is an ARM-based microcontroller. 3RT6. See, this is an industrial microcontroller. Okay, so this microcontroller is provided by STM Electronics, and it's most widely used for controlling motors and controlling drivers. and most of the firmware is written in Chinese. So for you to understand the basic firmware or the bootloader properties of this microcontroller, you'll have to convert that into English and then understand. Okay. So a MCU, and then there are memory systems. Okay. So it has flash memory. Okay, there is MCU. Sometimes your MCU itself has flash memory, or sometimes it has a separate IC to store code or store memory. Okay, and then there is input to output interfaces. So in just like these pins are called GPIO pins, general purpose input output pins, but your PLCs have input and output pins labeled on the PLCs. One second. Okay, this is your PLC. So these pins are your input pins and these pins are your output pins. Okay. So, and these are your debug ports. Okay. So we take sensor input from these pins and give out actuator output from other dedicated output pins. These output pins are connected to sugar cube relays or tracks there. Okay. So this is your memory interface, and architecture of your Siemens S7-1200 is it has a ARM Cortex M3 core MCU, okay, which is also known as Octopus. Okay, and this is connected to your Ethernet cable. Okay, Ethernet cable gives data to your MCU, and this is how your PLC is discovered inside your network. So how is this PLC recognized inside your network? Any idea? How can I say that this specific PLC is inside my network, and how can I communicate to this PLC inside the network? IP addresses, yeah. So it is connected to, let's say there is a microcontroller, and this microcontroller is connected to a Ethernet shield. And in PLCs, we mostly have W5500 module. Okay. W5500 is a Ethernet module. It's a VisNet Ethernet module. Okay. So this module has its own MAC address. Okay. This is the IC of W5500. And one second. This is your pinout, how your W5500 is connected to your microcontroller. Okay. So this module right here gives your MCU access to communicate within your network using Modbus TCP protocols. Okay. So this is your Ethernet module. So this module is connected, and it gives once this module is connected to your MCU and it's connected inside a network, it turns on the DHCP addressing, and it is given a specific IP address. Let's say one of your microcontroller is connected in 192.168.36.2. Okay, this is your range. Okay, so your other microcontroller will have similar address 192.168.32.3 or 4. Okay, how it depends on how many microcontrollers are connected. So this is how your IP addresses are segregated, and we will further understand the network map on how these PLCs are discovered in our coming sessions. But for now, just understand that it has a W5500 shield connected that helps in Ethernet communication. And then there's a flash, SPI flash is used to process sensor inputs and give out output. And then there are extension ports. Extension ports can be your interface pins for display outputs or any other buttons. We can have buttons on the panels, and we can control these PLCs from the onboard panel buttons as well. Okay. So these all are the extension port pinouts. We use universal asynchronous receiver and transmitter protocol as well. So a few PLCs that have been introduced lately are coming with a serial debugging port. Other than RS485, it is having a Type C port so that we can serially debug what is happening, and we can understand the input and output live during the manufacturing session. Okay. So I think with this, we come to end of understanding PLCs and PLC as a device. And anyone having any doubts regarding PLCs or how they are controlled in a SCADA system? You can have any kind of doubts. Okay. Let's say you have a project in mind and where you want to deploy a PLC, and you have a doubt if your PLC can do this, or if something is achievable, you can ask me right now. Okay. So this is the main endpoint of your field devices. This this is what connects your devices. About voltage, differential about voltage. Can you please tell me what exactly is your doubt? Differential about voltage in sense? Do you want to understand how voltage is being distributed inside your PLC? How much is needed for proper efficiency? Okay, so again, let me just check who has asked this question. Can you raise your hand? I cannot see your name here.
Sir, it was asked by Lakshmikant, sir.
Okay. So yeah. So Lakshmikant sir, this like to understand how much voltage is required for our PLCs to work efficiently, or what is the threshold volt, we need to understand the data sheet or instructions manual given by our PLCs. But most of our PLCs are used to work with 24 volts, 5 amperes current. So these the a minimum of 24 volts, 5 amperes is to be uh, given to your PLC to work on maximum efficiency. And if the voltage falls below 24 volts, then there are a few regulators that cannot work. So let's assume that you have a ARM based microcontroller. Let's say you have STM32. Okay, so for understanding this, 32F103RT6, we should download the data sheet. Okay, for a manufacturer or for a designer, we should understand what is the required current for the MCU and required voltage to run the MCU. Okay, so this is the data sheet. Okay, from here I can download the data sheet for this microcontroller. Okay, and this data sheet includes all the necessary documentations regarding the MCU. LCD panel interface, clock and setup, boot modes, supplies, EAMS, power supplies, supervisor, voltage regulator here, low power modes. So these PLCs have low power modes as well. So let's go to voltage regulator section here, page number 17. Okay. Please let me know if I'm audible. Hello?
Yes, sir, you are audible.
Yeah. Okay. Yeah, so I guess, yeah. So it says that it requires at least 3.6 volts to for the external clock to work at 32 kilohertz and the oscillator to back up the registers. Okay, so in order to turn this this basically runs from 3.3 volts to 3.6 volts. So now that our PLC is having 24 volts power supply, we can use a 3.3 to 3.6 volts voltage regulator. And if our voltage regulator is being supplied by 24 volts constantly, then and only then it will give us it will step down the voltage correctly and give it to microcontroller. If there is an unstable power supply there, then your PLC might have difficulties being discovered inside the network, because a few PLCs are also having GSM modules. So GSM modules are basically for your PLCs or these panels to control from to cellular network and to take real-time clock readings from satellites. Okay, so there are a few 800 carrier. One second. This is yeah. This here is your SIM 800L module. Okay, it's a GPRS GSM module, and
Excuse me, sir, the PPT
if
has stopped showing.
okay, one second. Can you see my screen now?
Yes, sir, it is visible now.
Yeah. So this is your SIM 800 LGSM module. So let's say you have a street that takes RTC real-time clock input from satellites, and once it is 7 o'clock in the noon, it will turn on street lights directly. And once it is morning, so like let's say it's around 6:30, it will turn off the street lights, or it is not detecting for any light source. It is working on static time clock interface. So these kind of GSM modules are deployed there. These modules are connected to satellites, and they take inputs in RTC input from your clock, and this is how that so this for these kind of modules to run, it requires at least minimum of 2.5 amperes to connect to satellites. There are other modules as well, sim 900L, that requires low current. But if we are using complex module PLCs or controllers, then I think uh, it is instructed to have a constant 24 volts 5 amperes input to your PLCs. And if it falls below that, then I think you should get your power module checked, or SMPS, which is powering your PLC, because this is very important for your stability, and there are a few monitoring mechanisms that monitor input voltage as well. And with this being said, I think we are clear with the PLCs, and we can go. And so most of the data and transmissions are unencrypted in such systems. And how to ensure? Okay, one second, let me. So Mukul has asked, sir, most of the data and transmissions are unencrypted in such systems. So how to ensure data privacy and network security? So this is a very good concern, and this is why uh, PLCs have a, they follow a very legacy kind of architecture, and this is why most of the PLCs are exploitable nowadays. But yeah, so this data and transmission inside the PLCs have a very uh, unencrypted way of transmitting. But it is very important to understand what are the baud rates of the communication. Okay, so let's say there is a sensor which is sending data to your microcontroller at a baud rate of 9600 bauds per second. Okay, and what is baud rate here? What do you understand by baud rate, Mukul? Do you know what a baud rate is? Hello. So if you don't know what a baud rate is, yeah, symbol per second. Okay. So I will tell you what a baud rate is. So for example, let's assume, Mukul, you are a microcontroller and I'm a sensor. And when I talk to you, words per second, like my talking speed should be equal to your receiving speed. Okay, your comprehending speed should be equal to my talking speed. Let's say I am telling you that tank number 5 is up. So this is me speaking in a specific speed, and your comprehending speed was in 9600 watts per second. So you understood. But what if I tell you sort of like sir, tank 6 is filled up? So this is me talking slow and you can comprehend it. But what if I talk in a very speed way? Let's say I have completed my sentence in 500 milliseconds. So can you understand that? No. So for me to communicate in 500 milliseconds, you should have a comprehending speed that can comprehend in 500 milliseconds. So this is how your peripherals inside the PLC or inside the systems communicate with each other. They have a specific baud rate. Okay. So these PLCs are there are very baud rates followed. 115200 is a common baud rate. 9600 is another.
Uh, Sushant, one
When
minute.
I have a PLC.
Hello, Sushant.
Yeah. Hello.
That how you can how like the answer for the question that he asked, how we can secure for the legacy and the unsecure protocol. Okay, so we do have a like
Yeah.
segmentation and isolation. We can create a zone and conduits, and we those assets in an air gap network. Air gap network means that we are not connecting with any other system which is connected to your IT to OT convergence. Okay, so we can keep that most critical system separate from external connectivity. Then we can implement access and identity control. That's the second approach. Then yes, we do have other way as well as then we can upgrade uh, the security the PLCs firmware and so software, because new PLCs are coming up with the encryption mechanism. If we have the possibility, we can do that. If not, because of the legacy systems, we have to keep it in a air gap network. Air gap network is keeping separately. We are not connecting that system to external communication. Okay, and then place the monitoring and detection systems, and we do have a Nozomi and Clarity solution for it. Okay.
Okay. So I was coming to that point. Thank you for saying that. So uh, this encryption is basically yeah, baud rate per second instructions are processed inside CPU, and CPU processing speed is called baud rate. Exactly. So this has to be very unique baud rate for your inter-system communication. So all your peripherals should have a unique baud rate of communicating, so that if anyone possesses your PLC, they should not be able to understand what your GSM module is telling to your microcontroller. Because if you know how your GSM module is communicating to your microcontroller, you can make a malware that can communicate with your microcontroller saying that, hey, I am the GSM module in the same interface. So in order to make the reverse engineering process hard, you can use complex baud rates. This is for your PLCs. And as per the encryptions and the data transmissions are unencrypted, there are like, yeah, like clock frequency in the processor. Exactly. So this is used, baud rates is a step that is used for your PLCs, or let's say to develop the product, to make it hard to reverse engineer. And because once your product is reverse engineered, you can design specific malwares and you can sell in the industry as well. Okay, so this is as per your hardware part. But when your PLCs are communicating in a network, you can segregate those PLCs to a separate isolated network, Mukul. Let's say you have three PLCs running inside your home network, and if an attacker, or let's say if I am a guest and I come inside your house and you give me access to your network, you should have a specific guest line so that I cannot discover your PLCs inside the networks. Because since you have mentioned your PLCs are communicating in unencrypted context, I can use Wireshark or other tools to understand what data is being transmitted. So for that, you should implement a virtual LAN for guests, a virtual LAN for your workstations, a virtual LAN for your CCTV cameras, and another virtual LAN for your PLC. So that if me as an attacker tries to hack inside your network and takes access from your laptop, when I come inside your network, I can only see your workstations, or I can only see your cameras, but not your PLC. And as Pankaj sir has told, with the Clarity. So Clarity is a company, and you protect your so our cables are very easily possible. So which implemented. Hello.
Yes, sir, you are audible now.
Yeah. Okay. Now I'm audible. So yeah. So as I was saying, these third-party softwares like Clarity and other solutions are used. So if I have a power plant, I'm running a nuclear power plant. I will make sure that, yeah. Okay. So yeah, can you see my screen now? So yeah, which is policies, and we can use other third communication with your and how this communication is two major terms. So people don't with network. Hello, hello.
Yes, sir. You're audible again.
Yeah, okay. So I think with
Sushant,
yeah,
uh, in chat I have pasted the all the steps which we need to take to protect the legacy
okay,
systems and the protocol. You can just read it
yeah.
out, and if anyone have any question, they can ask.
Okay. Yeah, I think this has this is self-explanatory. So there are a few methods where you can make sure your data is encrypted and it is not accessed to unauthorized users. So there are encryption and secure protocols using VPNs and secure tunnels. You can have protocol hardening, replace plain text to Modbus C. This protocol hardening modules are already being used, but there are a few PLCs that communicate on plain text. Let's say there is a automation system in your office or in your corridor. So that is connected to a PLC and that will, sir, my actual question is these, in all these conditions, now we are facing network signal and in the real environment, voltage is varied. Sorry, your question, I cannot understand what you're actually asking here. We are facing network signals and in the real environment, voltage is varied. What do you mean? Lakshmikant sir, can you please elaborate your question? And this is a simulation of your OT power grid human to machine interface demo. And we will explore this in the next class. For now, let's clear your doubts and sum up with the morning session. And we can continue with few demonstrations and case studies and start the simulation lab afterwards. Lakshmikant sir, I'm waiting for you to elaborate your question. And if you guys have any other questions, you can ask in the chat as well. About the voltage, how we regulate actual, how we regulate the actual for better performance. Okay, about the voltage. So, Lakshmikant sir, voltage is being regulated by specific ICs. Okay, for let's say if we want to regulate voltage 5 volts, we have 7805 IC. Okay, so this is a onboard voltage regulator, and if I supply it to my MCU, I've changed my net. Am I audible? I have
Yes, sir, you're audible.
this is again, I think there's a problem. Yeah. So you choosing correct hardware for your voltage transmission. Again, same thing, no voice and video. I'm audible now?
Yes, sir, you're audible and screen is visible too.
Yeah. So choosing right hardware for your PLCs is very important. Choosing correct hardware and making sure the input supplied voltage is accurate so that it can be few other AMS 1117. AMS 1117 is a very good choice if we want a 3.3 volts output for our microcontroller. AMS 1117. So these all these voltage regulators are very easily available in market, but choosing best voltage regulator is what that matters, because if your voltage regulator is fluctuating a lot, then you should make sure that a set of capacitors are connected. And this is when you are manufacturing a PLC, okay, to make sure that your PLC is not facing any problem with the voltage and it is able to perform better performance every time with given voltage. You have to make sure that your schematics are withstanding all the voltage conditions. So I think with this, you can your doubt is clear that how we can make sure that the performance is good throughout. We have to make sure that the schematics can withstand any kind of voltage conditions here. Okay. Any other questions? And if we don't, yeah, okay. If we don't have any other questions, I think we can sum up with today's session, the morning session, and see you guys in the evening.
If there are no more questions, we can go to end the session.
Yeah. Can we wait for 5 minutes?
Yes, sir, yes.
Yeah, okay. Yeah. So if you have any question related to yeah, yeah, if you have any questions related to OT or industrial control systems. Yesterday you told we will have simulation exercise today. Yes, we have simulation exercise today. Your lab is made and it is deployed online and it is planned now. But in order to understand the simulation lab, I wanted you to understand PLCs and all these anatomy first, so that you can understand what is being done in the lab. You can understand each and every command. So yeah, it is planned for today. You will have one more session in evening where we will explore this power plant. Okay, this is power grid HMI, and then we will have a case study of nuclear we'll have a case study for a nuclear power plant, and then we'll have a case study for Ukraine power grid attack. So Ukraine power grid attack was done with two different strategies. So we'll be understanding those strategies as well. No credentials were shared for them. So yeah, actually your credentials are your name and your registered email. That's it. We have hard coded your credentials in the lab, and it is deployed on the server. And please make sure you utilize this opportunity and you use this lab, because this lab is only for today, and after 12 o'clock today we will stop the will change the credentials, because this was only designed for the course curriculum, and there are few other courses. So these labs come with the course, and this can be accessed only during the course. So please make sure that you utilize this opportunity. So evening, we will explore few attack scenarios and few other peripherals, and then we can I will be guiding you guys with the attack first, and we'll be using the lab, and then I'll be giving you access to the lab. You can uh, exploit all these malwares on your system, and once that is done, the system will create your own certificate and give it to you. Please let us know format in which we need to input the credentials. Your username is capital, and your email is normal case sensitive small. Okay, we will be giving you your credentials by evening. Please be in touch, and I have already shared the credentials with uh, your organizing authority, and they'll be sharing it to you guys. Apart from that, do you have any other questions regarding this? If not, we can sum up the morning session.
I don't think there are more questions, sir. No, there is one.
Yeah. Yeah. Are there any tools to simulate attacks on OT infra, open source? There are no tools to simulate attacks on OT infrastructures, which is why Black Layer Labs and Armor Innovate, we are coming in the market with these simulations, and you will be experiencing these simulations in the evening today. But unfortunately, this is not open source, and this is only for educational purpose. So we provide these tools to simulate attacks. We have programmed these PLCs on remote servers, and you can experience this in the evening today. Please make sure you have this exposure so that you can understand how these industrial grade attacks were carried out. Okay. So as of now, there are no open source tools because this is very dangerous to uh, you know provide a game to attack OT infrastructure, because these manufacturing machines are very costly, and if people are if wrong authority is being trained, and if they have uh, geared up tools to attack any OT environment, I think this can have a very big and dangerous impact on the system. So yeah, there are very few courses. Yes, sir. So yeah, exactly. So we will continue with the lab in evening. See you guys in the evening, and I think we can sum up with the morning session. Thank you, everyone, and I hope I was very much in line with your comprehension. And since I went with Atmiga 328P, I hope that you understand PLC a lot better now. Yeah.
Mhm. I think,
Okay.
sir, so you have addressed everyone's questions, and I think most of them must have understood. Uh, on behalf of all the participants and Vikas sir, I thank you for today's knowledgeful session, and we would meet at 4 p.m. I would request all participants to join on time so that we can address whatever issues you may face later. Uh, And with this, I think we can end our session.
Yeah.
Thank you very much, sir.
See you guys at 4 p.m. Thank you. Thank you, everyone.